Hello, today we're in the while loops chapter of Learn to Code 1, and we're in the sixth activity called Land of Bounty. Okay? Land of Bounty is a challenge, and up at the top it says we should experiment to find an efficient solution that works for you. And it also mentions that the length of the platform that Byte is on can change or can vary each time we run this puzzle. Okay. Right now there are 4 switches on here and a blank space, so 6 tiles long actually. If we run this again here, I say run the code and I run it again, this time it's shorter. And it's shorter because we've got these blocking walls at the end of it that happen a little closer this time. So now instead of the 4 switches we have to take care of, now there are only 3 switches, then 3 gems, then 3 more switches. Notice that each time we run this, not only does the length of it vary, but whether or not the switches are toggled on or off also varies. Okay, one more time. Okay, so let's get a plan here for maybe taking care of the first row. So this time the row got a little longer and we'll need to take care of 4 switches here. So since we don't know how many switches we need to take care of in this first row, it probably makes more sense to use a while loop instead of a for loop, since the number that we need to take care of changes each time. Instead, we want to use a condition to tell when we want to stop toggling switches. And in this case, do you have an idea on what we want to do? What kind of a condition we can use to tell us when we have to stop? Yeah, it looks like there's either a wall at the end of the row, or sometimes when you run it, the wall's totally gone and there's a cliff. But either way, we'll be blocked at the end. So maybe one plan would be to say something like, as long as we're not blocked, just keep walking forward and toggling switches. Okay, let's try that in some code here. So that's as long as we're not blocked, or while we're not is blocked is true. We just want to keep moving forward and toggling switches. Move forward, toggling switches. Okay, and when I say that, I'm really talking about some abstract idea, move forward, toggling switches. But we could go ahead and write that in a function if we wanted to. We could also put the code right inside this while loop. But I like putting it in a function because it's a fairly complicated procedure and I don't want to worry about the details. Once I write the details of how do I move forward and toggle a switch, I don't want to think about that anymore. Okay, and that's what you want to do when you're talking about abstraction and putting things in a function. Move forward, toggling switches. Okay, and to move forward and toggle a switch, well, we're just going to write the code for that. Move forward, and I could just say toggle switch here, but I need to be careful because some of them are on already. And if they're on, we don't want to toggle a switch, only if they're closed. So we can say if we're on a closed switch, then we toggle the switch. Okay. Good. So this should hopefully take care of one row, like this first row here with switches on it. Let's go ahead and try that. So this says as long as we're not blocked, we want to just keep move forward toggling switches. Here's a nice short puzzle. So checks if it's closed switch, we toggle it. If not, just keep moving forward. Okay, good. Byte stopped when he was blocked. He didn't try to go any further. So that's good. Now, after we handle this first row here, we would maybe like to get us set up on the second row of gems. So how will we get over there lined up so that we can handle this second row? Well, we're just going to want to do a turn to the right, then a move forward, and another turn to right will get us set up looking down this row of gems in this direction right here, so we can clean up that row of gems. Now, this little move here where we're going to turn a corner is used so often, this is another good candidate for maybe writing this in a function to abstract the idea of turning a corner to the right. Instead of having these 3 lines of code here, wouldn't I maybe rather just say turn corner to the right? Something like that. Okay, and we can do that if we make a little function up here, func turn corner to the right, which just contains all these 3 things here. So I'm going to cut these out of here and say move corner to the right or turn corner to the right will just be a turn right, a move forward, and a turn right. Okay, so here we've got a while loop that takes care of the first row of switches. Then we turn the corner to the right, and we should be ready to collect all the gems on that last row. I'm going to just make sure this works. There's a nice long puzzle. So he's going to keep toggling switches if they're closed. Here he'll be blocked at the end, so he won't do that. Instead, he'll turn corner to the right. Good. He's set up to handle this row of gems. Okay, handling row of gems is going to be a lot like the handling a row of switches, because we're just going to need to keep moving forward however many tiles there are. We don't know what that is, but we do know we want to stop collecting gems as soon as we're blocked. Okay, so this makes sense to make this a while loop also. While we're not blocked, we just want to keep moving forward, collecting gems. Move forward, collecting gems. Okay, that's our abstract idea of what we want to do each time we're on a tile in this second row. So let's make that a function. Okay, func move forward, collecting gems. And we're going to do the same thing we did with switches. We're going to move forward, then we're going to check if we're on a gem. If we're on a gem, then we collect it. No reason to collect a gem if we're not on a gem. Okay, so if we're on a gem, we collect it. All right, so this while loop should clean up the second row there. Now, after we get to the end of that second row and we're blocked by this cliff over here, what do we want to do? Do we want to turn right, turn corner to the right again? No, this time we need to turn a corner to the left, right? Turn a corner to the left. So again, let's abstract that idea here and say turn corner to the left. I don't want to see all the code to do that down here. I'd rather put the details of that up in its own function. And that way I can use this function in some other puzzle sometime, maybe if I ever need to turn corner to the left. Turn corner to the left. Okay. Turn corner to the left is just a turn left, then a move forward, and then a turn left again. And that will get us facing down this last row of switches ready to go on that. Okay, so let's go ahead and we'll run this quickly. Here we go. Handling the row of switches, turns corner to the right, collecting all the gems as long as we're not blocked, and then turning corner to the left. So good, ready to go. Here we could just do this while loop again, right? Which handles a row of switches. But in fact, this might read a little bit better. Instead of me copying this 3 lines of code in here, I'm going to abstract that idea into a function as well. Handle row of switches, we'll call that. And up here too, I'm going to replace this while loop. I'll go ahead and cut this out of here, and we'll write a function handle row of switches, And all that happens in there is we do our while loop that says as long as we're not blocked, we keep moving forward, toggling switches. So our main program now says we want to handle a row of switches, then we want to turn a corner to the right, then we want to handle a row of gems, right? Then turn a corner to the left and then handle a row of switches. Well, let's be consistent here. If we're going to make our handle row of switches be one line of code, let's do that also for our handle row of gems. So func handle row of gems in here will just be this code right here. Let's get this out of here, cut it out of here, paste it in here. Okay, and now instead of that while loop in here, we'll say handle row of gems. Okay, so let's look at our main program now. Our main program is from here to here, and really it reads very nicely. It's like just a simple outline of what we want to do in this puzzle, which is first we want to handle a row of switches, then we want to turn a corner to the right, then we want to handle a row of gems, then we want to turn a corner to the left, and then finally we're going to handle the last row of switches. All right? Good. Let's run the code, and I'll run this by stepping through the code so we can watch it step at a time so we can see the functions getting called. We're going to move forward toggling switches because we're not blocked. We check if we're blocked again. We're not, so we move forward handling switches, toggling switches. We're still not blocked, so we move forward toggling switches. Now we're on a closed switch, so we toggle it. We're still not blocked, so we move forward toggling switches. And we're still not blocked, so we move forward toggling switches. We're on a closed switch, so we toggle it. And we're still not blocked, so we move forward toggling switches, which is just a move forward here. And now we come down and we're going to turn corner to the right because we were blocked. After turning corner to the right, we call handle row of gems, which is just going to keep moving forward as long as we're not blocked and collecting gems. Still not blocked, we move forward and collect a gem. Not blocked, so we move forward collecting a gem. Still not blocked, so we move forward collecting gem. And not is blocked is still true, so we move forward collecting a gem. And now we say, are we blocked? No, not yet, so we move forward, but no gem to collect, so we're done with this while loop because now we are blocked. So now we call turn corner to the left, and then we're going to call handle row of switches, which is just like the first time, where we say if we're blocked, we don't do anything, but if we're not blocked, we go ahead and move forward toggling switches. Still not blocked, we're moving forward toggling switches. Still not blocked, move forward toggling switches. Still not blocked, move forward toggling switches. Still not blocked, move forward toggling switches. And still not blocked, move forward toggling switches. This time we will be blocked, so we'll be done. All right. Nice. This is a real nice bit of code here. We've really got this main program down to just its basic abstract ideas. Handle a row of switches, then turn a corner to the right, handle a row of gems, then turn a corner to the left, then handle a row of switches. So if we were to leave this program and come back to it, a year from now, and we wanted to know what this program did, we could look at the main program here and just really simply read and say, oh, okay, I see. This is going to handle this row of switches. Then when we're at the end, we're going to turn a corner to the right, and then we're going to handle the row of gems coming back. Then we're going to turn a corner to the left, and then we're going to call handle row of switches again, which will take care of the last row of switches. So we don't need to know what all the details of all these things are in here. We can if we want to. If we want to know what turn corner to the right does, we can come up here and look at it if we want to. But if we don't want to do that, this is a lot easier to find some places we might want to insert new things or reuse some of this code or just find out what this program does. It's a lot easier to read if we write it like this, okay, with these main ideas written as functions that may in turn call other functions. Okay, now before you go here, I want to talk about one other way we could handle this, and there are some new things we may learn in here to do this. But I know some of you probably looked at this puzzle and said, you know what? Every time this puzzle regenerates, every time we make a new version of this puzzle, there are always 3 rows in it, 3 rows to handle. So you probably thought to yourself, or you may have thought to yourself, I wonder if I should be doing that in a for loop. Okay, so you may have done something like this. For I in 1 to 3, for I in 1 to 3, I really want to handle the rows, handle each row, right? Because there are 3 rows. That might make this program even easier to read. I don't know yet, but it might. So let's run this just to get a bite back to the beginning here again. Okay, he's back at the beginning, and I'll stop him. Now, the handle 3 rows, one thing that may cause a problem with this is that we're not doing the same exact thing each time for each row. We're handling a row, but since the rows are a little different, sometimes they contain gems, sometimes switches, we may need to adjust for that, okay? And that's where this new idea comes in. So, how are we going to do this? Well, let's get rid of this code first before we think about this. All right, handle each row. So what does that mean? Well, the first time through this for loop, I want to handle a row of switches. The second time through the for loop, I want to handle a row of gems. And the third time through the for loop, I want to handle a row of switches. So that's what I'm saying. They're not exactly the same thing each time. So can we deal with that? Well, we can if we know which iteration of the for loop we're on each time. Okay? And it turns out that's what this little I does here. This I is what we call a variable, or a counter in this case, that counts through the sequence 1 up to 3. So the first time through our for loop, I will have the value 1. The second time through the for loop, I will have the value 2. And the third time through the for loop, and the last time through the for loop, I will have the value 3. Okay? So we can use that actually to our advantage, along with some conditional code to decide if we're on the first iteration, the second iteration, or the third iteration. Okay? Now don't worry if you don't know how to write this. I'm going to show you here how we could write this conditional code. But we could say if the iteration we're on, or if I is equal to 1, we know we're on the first row, first iteration in the for loop, or if I is equal to 3, we know we're on the third iteration through the for loop. Well, if we're on the first or the third, then I know we want to call handle row of switches. Okay? Because that's what the first and third rows are, rows of switches. And after we handle a row of switches, then we want to turn the corner to the right so that we're ready for the next row. Okay? Now, we could say if we're not on I equals 1 or I equals 3, we'll be on I equals 2. So in an else statement, we could say, otherwise, we want to handle a row of gems. And after we handle a row of gems, we want to turn the corner to the left. Okay? See what we did there? Now we put them all in a for loop, and we said if we're on our first iteration or our third iteration, that means if I is equal to 1 or I is equal to 3, we want to handle a row of switches and turn to the right. If we're on a second row, a second iteration through the for loop, we'll handle a row of gems and turn our corner to the left. Let's try this. Let's go ahead and run this faster just to see if this works. Okay, first time through, I is equal to 1, so we're going to handle a row of switches and then turn to the right. Now I is equal to 2, we're going to handle a row of gems and turn corner to the left. And now I is equal to 3. We're going to turn a corner to the right and, whoa, whoa, did you see that? Bite almost fell off the edge there. Yeah, he almost fell off the edge. He did clean up all the rows and got all the gems and all the switches toggled, but at the end what happened is he tried to do a last turn corner to the right, and there is no right-hand turn there. There's just a cliff. So he almost fell off. So this is okay, but I've grown quite fond of Bite, and I don't want him trying to walk off the edge of the cliff here by turning corner to the right if he doesn't need to. So how can we fix this? Well, it turns out there's a couple ways. One of the safe ways might be right before we call turn corner to the right, we could check if he's blocked to the right. So if he's not is blocked to the right, then he can turn a corner to the right. Otherwise, he shouldn't even bother to turn a corner to the right. That's great, and this is an okay place to put this, but really, if you think about it, we don't want Bite ever to turn a corner to the right if he's blocked to the right, do we? So maybe this if statement, this if block in here, let's go ahead and just call turn corner to the right, and really we should put that check actually in the function turn corner to the right. If we put it in the function, then anytime anybody ever tries to make Bite turn a corner to the right, it'll first check and see, is the right opened? Is the tile next to Bite to the right open? Then go ahead and turn to the right. If it's not, we won't do anything in here. Okay, that'll keep Bite nice and safe. All right, so if is not blocked to the right, then we want to do these 3 things here. That's the only way we ever want to turn a corner to the right, is if we're not blocked to the right. And we should also, even though we don't ever do this in a not safe place, we may use this code some other time, and if we do, let's make it nice and safe by saying if we're not blocked to the left, then we should turn to the left. Okay? Makes a little bit more sense now, doesn't it? Now these functions are nice and safe, and nothing bad can happen to Bite if he ever tries to turn a corner to the right, or if he tries to turn a corner to the left and there's a wall there or a cliff there. He won't bump into it or fall over the edge. Okay? Let's run this one more time here. We'll just run it faster and make sure that this turn corner to the right won't make him try to fall off the edge now. Okay, got a lot of switches to toggle this time. Here's our turn corner to the right. He's not blocked, so he can turn the corner to the right there. Same thing with this. He's blocked to the front, but he's not blocked to the left, so he can turn corner to the left. Now let's see if he tries to fall off the edge. Nope, perfectly safe there. Okay, all right. So I like these equal, right? I don't think this is, maybe this is a little more difficult to read because you've got this conditional in here that says if we're on row 1 and 3, we handle the switches. Otherwise, if we're on row 2, we handle the gems. However you like to do it, I know some of you were probably thinking, wow, there's 3 rows in here. I should be doing this in a for loop, but maybe couldn't quite figure out how to do it. I just wanted to show you how that would be done. Remember, review here is we did lots of nice abstraction in this puzzle. And by abstraction, we mean let's write some functions which let us say really abstract ideas or big picture ideas like turn a corner to the right, and then we won't worry about the details after we wrote it. Okay? Or handle a row of switches. Well, that's a nice abstract idea. It's a big picture kind of a thought. But if we want to know what the details are of that, we can come up and look inside the function here and see that it's a while loop that just checks as long as we're not blocked, we keep moving forward toggling switches. All right? Okay, good job everybody. This is a good one to practice if you wrote it differently and you like one of these solutions a little bit better. Maybe take a couple days off, come back and open your Land of Bounty, delete your code, and see if you can write it again using abstract ideas like we did here. All right, see you next time.